Okay, welcome to part 2 of the final exams. It is going to be questions 6 through 10, and it's predominantly trigonometry, which has been done in all the videos, but I'll show you how to do the ones on the final now. If you look closely, you'll notice that there's no part A here because there's only 2 of these on your final, and they're pretty simple to do, but you do have to show a little bit of steps. So I'm only doing the 2 types that are there. You have a negative half power and you have a 2/3 power. To do a negative power, you flip it over, right? Take the reciprocal, and the power changes from a negative to a plus, right? You can't do a negative power, you have to make it positive. The way you do that is to flip it over. Now, you have to remember that the 1/2 power represents the square root. So I'm looking to do the square root of 25, which is 5. So you get 1/5. So these 2 steps, right? If there's only 2 of these in the final, and this is a 10-point question, then they're worth 5 each. So if all you wrote is 1/5, yeah, I can tell you that you're probably going to get a -4. All right, you need to justify every single thing that you do. The first justification is to switch the sign. The next is to put the square root and then take the square root. So if these are missing, that's your work. The answer is almost meaningless to me. All right, and you're not going to get a lot of points, if any, if you skip the justifications. Like again, here, the first step is to remember that the bottom number is the root. So I'm looking to do a cube root. Now, you have to be very careful. There is a difference between this and this. Here, you're taking the cube root of -64. Here, you're not. This is, I understand it's -64, but these are different. This means -1 times 64, but you have to do the power first. It's kind of like this thing, where if I asked you that, you're like, oh, it's 9, it's -3 times -3, but that's not true. This is -3 times -3, which is +9. This one is -1 times 3 times 3, right? You have to do the power first before you do multiplication. So this one would be -9. So this minus is in the front. It's very easy to make this mistake. It's ridiculously easy to make this mistake. The cube root goes there, and the 64 goes here. And now you say, what do you do with the 2? I put my -2 too close. The 2 goes there. So first you have to take the cube root of 64. So you're asking yourself, what times itself? 3 times makes 64. Well, 4 times 4 is 16. 16 times 4 is 64. So you get a 4. And then you have to square it. Now again, you have to be very careful. This is not -4 times -4. It's 4 times 4, and then you hit it with that negative. So 4 times 4 is 16. Then you hit it with the negative. That's kind of one step, but so you have to be real careful with that problem with the signs. It's ridiculously easy to screw it up and just put this negative in there and then end up with a +16 at the end, all right, which would be wrong. Just be very careful on that one. Those are the 2 on the final, not A. That's why I didn't do A, all right? Okay, starting with question 7 is where all the trigonometry is, and it's basically every trig topic that we've covered. So, well, that I didn't cover, unfortunately, but all the videos were there and all the lesson notes were there. So I'm going to do B first because it's a little quicker. It's ridiculously simple, right? You have that chart. I'm not putting the chart here because it takes up too much room. So you just need 2 things, right? You need a reference angle and you need a quad. Now, 150 happens to land in quad 2. And the reference for this, you just do 180. Take away 150, so it's 30 degrees. 30 degrees in quadrant 2 is equivalent to 150. So you would look on that chart. So basically you're doing the cosine of 30 in quad 2. Now in quad 2, only sine is positive, right? So he will be negative. And I need 30 degrees. That number is going to be radical 3 over 2. I'm going to give you a little hint here. You're never going to be asked to find the exact value and get the -1 over 2 or +1 over 2, right? Which is 0.5, because the calculator will give you 0.5. And that can't be marked wrong. This question, if you decide to do it on the calculator, you just get -0.866, which is wrong because it says find the exact value. So you're never going to see an angle that gives you a half there. You're either going to get radical 3 over 2 or radical 2 over 2, or you'll have tan there, where you get radical 3 or 1 over radical 3. Those are the only, you're never going to get a half here. Never, right? On the final. Now, this question It's what we've done already. It's just disguised. It's deceptively easy. It's really, this entire question is really just the Pythagorean theorem. I think I copied that wrong. There should be a radical there, if I'm not mistaken. Yes, it's radical 7. Now that I'm looking at it. So you draw a right triangle. You know, again, you're not going to have a tremendous amount of room. You're going to put theta here. We don't care about the angle. Sine is opposite hypotenuse. So you put those two sides there, right? The opposite side of the hypotenuse. All I need is this side, right? I know that tangent is opposite over adjacent, right? Tangerines are apples. So toa. So I just need that side. So you have to use the Pythagorean theorem. Be careful here. A squared b squared equals c squared. How do you know what c is? C is always the hypotenuse. It's always the diagonal. It's always the side across on the right angle. So x squared. Now, radical 7 times radical 7 is radical 49, which is 7. You're squaring the square root. Hello, you get the number inside. This is 16. Subtract the 7 over. So you get x squared. 16 minus 7 is 9. Wow, this came out so nice. So you get x equal 3. It may not come out nice on the final. You don't know. And to be honest with you, I don't know either. So you get this side to be 3. So the opposite side is radical 7. And now I know the adjacent side, right? This is op. This is adj. So you just read it right off of there. So the tan of theta is equal to radical 7 over 3. Very simple question, but you may not know what to do when you see it. You're like, what the hell? You just have to make the triangle. It's really, this whole question is really just, do you know the Pythagorean theorem? And do you remember the trig ratios and who goes with what sides? It's a pretty simple question. All right, so question 8 now. There's no way in the world that I'm going to write these down, so I'm just going to read them. The part A has a boat at the bottom of the lighthouse. So, you know, draw your lighthouse. And then you got a boat down here, right? This is supposed to be water, but I want to make it look like a triangle. So then it says that the boat is 150 feet from the bottom of the lighthouse, right? So you have to put that there. And then the lighthouse is 220 tall. And you want to know the angle of elevation to the top of the lighthouse. I drew this horribly. Angle of elevation is right there. I like to call it theta. You can call it X, you can call it whatever the hell you want. I don't care, you can call it A. So I'm looking for the angle of elevation to the top of the lighthouse. So again, you have to just use trig ratios to do this. You don't have the hypotenuse. You have the opposite side and you have the adjacent side. So then that's going to be tan. So the tan of angle theta that you're looking for, I need the angle of elevation, is the opposite side, which is 220, over the adjacent side, which is 150. So this is the first part of the question. I have to see that. Now I need to solve for theta. So you have to get rid of tan. Divide both sides. No, you have to do the inverse tan. You have to write this properly. If this is written incorrectly, you're going to lose points. And if you skip this step and just do it on the calculator, you're going to lose points. This is very important now. I have to do it on the calculator because I don't know what the hell this is. So I do inverse tan, right? I hit second tan, and I do 220 divided by 150. That's all I can do. So I know that theta equals 55. I got 0.71. So if you want to see, it comes out blurry. Clear it out. So again, I need the equation using the trig ratio. I need the step you would plug into the calculator. And then I need the final answer there, right? I must see these 3 things. If any of them are missing, if all I get is this, or if you jump from here to here without this middle, this is very important. This is what you're putting in the calculator, and I have to see it. Okay, that's part of the problem. Now, question B says you have a ladder placed against the wall. So here's my ladder. Right, this is how you put a ladder on the wall. You don't put a ladder this way. Good. Why don't you try that and try climbing it, see how far you get. Now it says the ladder forms an angle with the ground of 61. Okay, my triangle went askew there. Now you're trying to reach a window that, well, it says that the ladder reaches a window that's 30 feet high. It's 30. How long was that ladder? Oh, you don't. That's what you're trying to find. Well, there you go. I was like, did I miss the part of the question? So you're looking for the length of the ladder. So you have a ladder, you put it up against the wall, right? There's a window there. The window is 30 feet off the ground. So somehow that ladder reaches that window. So the ladder is at least 30 feet, right? So, and they're telling you that the angle with the ground is 61. So now again, you got to pick your trig dude. You have the opposite side and you have the hypotenuse this time. So, right? Stupid old hobo or whatever, right? You use sine. So the sine of 61 is the opposite side, which is 30, over the hypotenuse, which is the length of the ladder, which is what I'm trying to determine. I need to know how long the ladder is. So you have to make an equation. Now, crisscross, right? This is what I taught you when I showed you. And I did this in the notes. This goes up, this goes down. So step one is to make the equation. There it is. Step two is to get the equation to where you're going to put it in the calculator, right? Make the equation. This is what you're going to enter into the calculator. You're going to do 30 divided by sine 61. And you know, I have to do the same damn thing you do. I can't do anything different. I have to just put it in the calculator. There's a glare there. So 34, the ladder is 34.3 feet. You don't have to put feet. I mean, we're not in a physics class. We're not going to go crazy over the units. But again, these are not difficult questions. You may misread it and mislabel your triangle, and then that's death because you'll pick the wrong trig dude, you'll get the equation wrong, and you get the answer wrong. So you get very little points if you draw the triangle wrong. You're probably going to lose 4 to 5 points, right? You know, I'll give you a point for writing something, but you know, you be careful. These are worth 5 points each. They're not worth 2 points or 3 points each. On the test, I had them worth 3 each. So if you completely blew it, I still gave you 1 out of 3 is not bad. But here, 1 out of 5 is not good. You don't want to lose 4 points on these. So be very careful that you label and draw them right. And as always, if you're uncertain that you drew it correctly, just come up and ask me. I will happily fix your triangle for you. Okay, question 9. These are the law of sines and cosines. They go together. It makes sense for them to be together because they're both non-right triangles. These are triangles without a right angle. So you don't have opposite, hypotenuse, all this crap. You don't have any of that. You don't have a right angle. So there's no hypotenuse, there's no opposite, there's no adjacent. So all the trig ratios that we were using to try to solve problems don't work here. So now remember what I said. The law of cosines can be very picky because it can be used to find sides. So, but I make sure that that doesn't happen on the final to you. So if you see I gave you 3 sides and I'm asking you for an angle, then it is the law of cosines. So this one's a little easier. So I mean, they're both about the same. So I'm just gonna do this one first. So now remember how you write the rule. Whatever letter is here, you put the opposite letters first. So if it's a C, you're going to put A and B. And on the bottom, you're going to put a 2, and you're going to put those same letters, A and B. The only place the letter shows up, this letter shows up, is at the end, right? So you do A squared plus B squared minus C squared. It's very similar to the Pythagorean theorem, but I mean, it's not, right? Because you don't have a right triangle. That only applies for a right triangle. So that's why you have A, B, and C, though. And that's why they're squared. So now just plug the numbers in. I mean, this doesn't get any easier. A squared, A is 9. I guess I'll write it. I kind of want to skip this. It's going to take too long. C is 12. So, right, A is 9, B is 5, C is 12. I'm being very careful because I know if I plug the numbers in wrong, I'm totally screwed. This goes here, this goes there. All right, now I'm going to multiply it all out. This is 81. This is 25. This is 144. 9 times 5 is 40 times 2 is 80. So, you know, and even if I can do it in my head, I won't do it in my head because I'm not a fool. So I get negative 38 on top and I get 80 on the bottom. So I have that cosine C equals negative 38 over 80, but I want C. So to get angle C, I'm going to do the inverse of the cosine. Again, you got to write this properly. The equal goes here. You don't put an equal here. You're doing the inverse cosine of that number. So you have to put parentheses there. This does not mean this is a product. This is not. All right. So again, I don't know what the hell angle that is. So I do inverse cosine. I do know that if you're using this calculator and you want to put a negative in it, this is really picky here. You can't press the subtract. You cannot press that. You see the difference between the negative that was on the bottom? It's blurry. And the subtraction. If you want to put a negative, you cannot press the subtraction button, right? The calculator it doesn't understand that. It gets confused and it doesn't recognize what the hell you're trying to do. So you have to press the negative button on the bottom to get the negative in front of the 38 and then hit divided by 80. All right, so that's what it should look like. Let me get rid of the glare there. It looks like shit. All right, so cosine C is, I got 118 point, it's 359, so I'm going to put 36. It's an angle, so please put the degree symbol. I don't like the way my angle thing came out. So, right, very straightforward. It's just plugging into a damn formula. You must know the law of cosines, so please, right, know what it is. Now, by process of elimination, this must be the law of sines. And look, I gave you two angles and a side. The law of sines uses two angles, so it can only be that. The law of cosine is not going to work here, right? There's only one angle in that whole formula. Everything else is sides. Here, you're going to use, now, I'm asking for side C. So I know that I'm going to need C over sine angle C. Now I got to look at everything else I have. I have angle B and I have angle A, but I have side A and angle A. So I must use that, right? I know this, 19. I know this, 64. I don't know this. I'm looking for this. I'm looking for C. So I need that. Fortunately, since I have two angles, we already did this a gazillion times. I need angle C to be able to plug everything all in. So I'm going to compute it. I'm going to do 180, take away 75, and then take away 64. So I get 41. Right? You need that angle. Now plug in everything you know. I don't know side C, I'm looking for it. I just figured out that angle C was 41. I need that, it's critical. Side A is 19, and angle A is 64. Right? This is important. I need to see that step. Now look, you can do this in one move. Take this dude here and go put him over there. And then the problem is over. You just do a bunch of button pressing on your calculator. Don't move the C, leave it where it is. So take sine 41 and throw it up across and multiply it by 19. And then you're going to divide that whole thing by sine 64. Now, how I do it on my calculator, I literally do 19 times sine 41 and hit equal, and I get that number. And then I hit divided by sine 64. So it's just a bunch of button pressing at this point. You really shouldn't get it wrong once you get here. So you get 13.8. I get 868, so I'll put 87. $13.87. So I do want to point out that, ordinarily, if you got here perfectly and you just had the wrong number, I'd love to not take off anything. I have to make the answer worth, like, say, 1 point out of 5. I can't make it worth nothing. The answer is worth something. So, but if you do press the buttons wrong somehow, and you got a different number here, like, let's say you accidentally got, 11 point something, I would only take off 1 point. I have to take off something. But all of this is like 4 points out of 5. The answer itself, I don't want to say it's irrelevant. It's not, but it's not the most important part of the problem. The important part of the problem is you recognizing that you're missing angle C, that you have to find it, and then just plugging it in and manipulating the formula so that you can, do everything on the calculator. It's not, these are not difficult questions. They shouldn't take you too long, as long as you know the law of sines and the law of cosines. You know they're there. And they're in the same question as part A and part B. So it's not confusing. They're together because they're both non-right triangles. So it should be very easy to recognize that problem. All right, we finally arrived at the last question, the trig equations, which I did teach you. So these can be very tricky. I wouldn't say they're hard per se, but it can be a little, there's places you can go wrong with them, but it's not that bad. Now remember, the goal is trig guy on the left, number on the right. Figure out what quadrants that angle has to be in and what the reference angle is, and then you can build the angles. All right, so it's a lot more complicated than doing this. Like if I give you sine of 150, this is 30 degrees in quadrant 2, and then you would tell me the number, right? In quadrant 2, sine is positive, and sine of 30 is 1/2. So right, when I gave you the angle, you had to give me the number. You're doing the reverse now. I'm going to tell you the number. You got to tell me what the angle was. So it's a lot more complicated in that direction. So now my advice to you was to take the first letter, and just, make the equation look like that. So it's easier for your brain to manipulate. right? I'm going to subtract 4 from that side. That gives me 5t equals 3t. 2 take away 4 is -2. Now I got to subtract 3t from both sides. Again, I like to cross them out when I eliminate them. 5t's take away 3t's is 2t's. Now you just divide both sides by 2, and you're going to get a -1. Now at this point, I'm going to put tan x. You got to put this back, right? You're solving for x. You know, it is tan, even though you put the t there throughout the whole thing to make it easier for you. So remember, 2 over 2 is 1, and it's negative. So I would look on my chart now, and I'd see that, okay, I know that my reference has to be 45, right? This is the only place that you get a 1 for tangent is 45. Now I need the quadrants where tangent is negative, right? Because you have a -1. If this was +1, you would be in quad 1 because everyone there is positive. Or you'd be in quad 3 because tangent is positive in quad 3. That's why the t is there. So, but I don't have a positive, I have a negative. So my angle cannot live there, and my angle cannot live there. My angle can only live there if this is a +1. So my angle must be in quad 2 and quad 3. I mean, excuse me, quad 4, sorry. I say the wrong thing and confuse everybody. So quad 2, quad 4. So in quad 2, you're going to take 180 and you're going to subtract 45. So you're going to get 135. In quadrant 4, you're going to take 360 and subtract 45. So you're going to get 315. It's very important that you subtract from the correct thing, or your angle won't be in the right quad. Okay, so get the trig guy alone, figure out the reference and the quads, and then build the angles. Again, it's not hard, but it can be if you don't solve it right, or you get here. It's very easy to put it in the wrong quad or make a wrong computation. That angle is definitely in quad 2. That angle is definitely in quad 4, right? Quad 4. I don't know what the hell I'm trying to write there. I was trying to write 270, right? It's 0 and 360. It's 90, 180, 270, 360. This angle is between 270 and 360, so I know it's in quad 4. I mean, you could check that it's in the right place. Now, this one is much easier to solve, but again, I'll put the s there just to make it easier for my brain. I'm going to subtract 2 radical 3 from both sides. Why? Because I need this alone. I can't have anything else with it. So I get 4s, right, for sine, is -2 radical 3. I'm going to divide both sides by the 4 that's in front of the sine. This is going to reduce. Now, it's important because you're not going to get the same number on the chart if you don't reduce this. 2 goes into 4 twice, right? So be very careful. That gives you a 1, that gives you a 2. So that means that sine x, which is what you're looking for, is, I can't believe I wrote, I fucking wrote 2 and then I wrote 3. I love it. I'm like, radical 3 over 3, that's tangent. All right, so we're looking for x, and you get negative radical 3 over 2. So again, you would look at the chart, you will have the chart. I'm going to give you the chart. You don't have to worry about making the chart and memorizing the chart. It's ridiculous. I mean, I know the chart. So I know that, for sine, you get a half, you get radical 2 over 2 and radical 3 over 2. So I know that this reference angle is 60 degrees. And again, I got to play my little detective game of where I am. I know that if this was positive radical 3 over 2, I'd be there. But it's not, so I have to cross that out. Again, if this was positive, I'd be in quad 2, but I'm not. So I must be in quad 3 and quad 4. Right? If the letters don't match, S and T, you're negative there. C and S, letters don't match. If the letters match, you're positive there. Right? S, S, the letters match, you're positive. Letters don't match, you're negative. So in quad 3, again, you're going to take 180 and add the reference angle. So my first angle is going to be 240. And then we just did quadrant 4. We take 360 and we subtract our reference angle 60 and we get 300 degrees. So again, they always have 2 answers. So if these are worth 5 points each, 1 point for manipulating the equation and getting the trig guy alone. So there's your 1 point, and then 2 points, 2 points. 1 point, 2 point, 2 point. So, this is how I grade it to make it easy, because it's tough to grade it out of 5. It's kind of weird. And again, on your test, I think I had them 3 points each. So you had a point here, a point there, and a point there. So, if you get one of the angles wrong, you're gonna lose 2. If you somehow screw up both angles, then you lost 4 points out of 5 on that question. You can see on this test, it's very, very easy to lose a lot of points in a hurry if you're making silly mistakes or, big mistakes. When the questions are worth 5 points each, every mistake you make is magnified with the amount of points you're going to lose. So, are the questions super hard? No. I can see many, many places where you can go wrong. And there's a lot of mistakes you could make. So, as always, practice the sheets that I put up there. I put them there for you. The answers are there. And, just keep going through them. Don't look at anything that isn't on that sheet. If it's not one of those 10 questions, you don't worry about it. Make sure that you know those 10 problems inside and out. You know exactly what to do, because time is a factor on that test. It's long, and some of the problems are long. So to finish it in an hour 40 minutes, if you are hesitant and don't know what you're doing and you're stuck and you're sitting there thinking, how do I do that one? You won't finish. All right, so make sure you know how to do everything and just keep preparing. All right, so hopefully this was helpful. As always, I'll just say I wish you good luck.